Next thing we are going to do is the following. I'm going to check how this function is executed by the machine, and we're going to see for a small value of n how does this factorial function gets executed. And we'll go through the steps of the how the execution for this function and try to understand it clearly what is happening here. And then and after that we will see how do you check whether a recursive function is written correctly. That is your argument correct? The recursive function you have written, is it correct? That's something we'll see how can we do that. That will be the next thing. So the first one, for a small value, let's say a value of 3. How can I say this function is correct? So I'm going to call this function. From our main program, for example, and call it fnc underscore factorial 2. So I'm going to call this function. So let me call it factorial 3. Okay. I'm going to call this function factorial 3. What is the output I want? I want 3 factorial or 6, right? This is what I want. Now I'm going to start running here. So first thing I'm going to do is I'm going to draw some blocks. Okay, and inside, so this is a block for the factorial function. Okay, so this is, I can write here fnc factorial. So this is the block for that function, and into this block I am sending for n is equal to 3, right? That's what I want to execute. So I have, when I enter this function, so I call n is equal to 3 from here. The function goes, so the machine goes here, it comes here, right? The machine comes there and it sees it's going to assign n is equal to 3 from there. So I have put n is equal to 3. Okay, and what does the machine do again next? So it's going to come here next. It's going to check, is n equal to 0? Is n equal to 0? Is 3 equal to 0? No. So it's not returning. Is n equal to 1? No. It comes next. X is equal to function factorial n minus 1. So that's the next thing which is going to be executed, right? Okay, so one thing, I mean, so this code won't be compiled because I didn't write what is x here. So it should have been, I should have had int x here, right? I should have defined it's an integer x. Okay, now so I have fnc factorial n minus 1, right? So that the function is called again with n minus 1. What is n minus 1 here? N is 3 now, as we know, and it's going to call n minus 1, 3 minus 1, 2. The function is again going to be called again, so n is equal to 2. So now when I'm going to call again, I'm going to draw another box here. I'm going to have a smaller box. That is basically again function factorial because it's called again, right? And what is the n value here? This is n is equal to 2. So note that the program is executing from here. So I am basically trying to copy what the program gets, how the program is getting executed. So it starts with n is equal to 3. It comes here and it sees n is equal to 2. And it sees so n is equal to 3 now, and then it calls the function factorial again with 2. That's what. So when I call this again, I have put because it's going to go here again, right? When this is called, it's going to go here again, but it's a different value of 2. So therefore I have written a block of code here. And what is going to be x in the first case? When I had n is equal to 3, it's coming down like this, and I want to assign x. What is the value x gets assigned? X gets assigned the value of the return of this, right? The return of this function called, right? So whatever this function gets returned, it's going to be assigned to x, right? So I have to first run this function and see its return, and that gets assigned to x. Okay. So I start from n is equal to 3, I come here, I reach here. So first I'm going to execute this function, and then that value I'll run there, get stored in x. So that's this block. So this block is basically this function call, right, with n is equal to 2. Now n is equal to 2 gets called again, so it goes there again. So n is equal to 2 gets called. Is 2 equal to 0? No. Is 2 equal to 1? No. So it comes here again. So again we don't know the value of x. Again to fill the value of x in this block of code. So we have an x here, right? So let me say initially I put x is equal to 0 here. So I have x is equal to 0 also here. Okay. So I have x is equal to 0 also here. In the first part of the code, x is equal to 0 in the beginning, and the second part of the second block also x is equal to 0, and but n is equal to 2 here. You should always keep in mind that these two x's are different. This x is in the first block and this x is in the second block. Okay, so I am here with n is equal to 2, I come here, these two things are not called, I come here, and I want to see, I call the function factorial with n minus 1. N is equal to 2 here, so I call it again n minus 1. So again, when I am going to call the function again, I have to write another block here. I draw another block here, right? And what is the, when I call this function again, what is the value with which I call that function? I call the value with 2 minus 1, that is 1. So I call this function again with value 1. So that becomes n is equal to 1. And so with n is equal to 1, this function gets called here. So it comes inside this and assigns x is equal to 0. And then it comes here. This statement is not executed right now because n is not equal to 0. Next is n is equal to 1. When n is equal to 1, this if condition is correct and it returns 1. Okay, so this block of code returns 1. Where did this block of code return to? Okay, how did this block get called? This block got called from the block with n is equal to 2. That block called this function and it wants to assign the return of this function to the x of this guy, right? Okay, so this return will be assigned to this x, right? So this x becomes 1. Okay, so I will write, so in this case I will write this as the following. So I will have x is equal to basically this block of code, right? Because x is equal to this block, so I am going to this factorial call again. So x is equal to this block, and that is basically the return value. So x becomes, at this point x becomes 1. Once this entire block gets executed, x becomes 1. That's the return value. Now, so x is 1. And then what does this block return now? This block is one function called, right? What does this block return? That block returns n into x. So what is the value of x here? The value of x is the return for this block, and the return for this block is 2. So the value of x we will note down here, x is equal to 2, right? Now, what is the return for this huge block? The return for that block is n into x, right? So return is this n into x, and you have to see what is the value of n in that block. The value of n is 3, and what is the value of x in that block? The value of x is 2. So the return is going to be 3 into 2, which is equal to 6. So the return is 6. Now that's correct, right? Because 3 factorial is 6. Okay. So the return from this, when I call this function, the return for this function will be 6, and it's correct. Now what I could do is that I can change it to 4. What happens if I write n is equal to 4? I call this function 4 factorial 4. Now to call factorial 4, I should have a box outside with n is equal to 4. Okay, I'm having a box. I'm having a box with n is equal to 4. Okay, and the box, so when n is equal to 4, you come here, and then you reach this function where it is the function called to factorial n minus 1 or factorial 3. So there is this function called to factorial 3. I already have this box for factorial 3. So I'm basically calling this box. So I could write it like exactly like this. I call this function factorial, the box for factorial 3, and get x, the return of this function. What is the return? The return is 6, therefore x is equal to 6, right? And then what will be the return for the execution for this outside block? The execution for that outside block is return of n into x, and that is return of n into x. N is 4, x is 6, therefore return is going to be 4 into 6, that is 24, and that's exactly what factorial 4 factorial is. So this is a block way to see the execution for your recursive function. Okay, and it's good to see get this pictorial view of execution. Okay, so we'll also try to code up this function in C, and see, and I'll also try to print this its execution, the run of the code. We'll try to print that, but only there will be only slight difference with this box notation, that it's difficult to draw this box, right? So since that's difficult, what I will print is we'll do a shift. There is a shift here happening, right? Already there is a shift here. So first block is all printed here on this line. The second block is printed after a shift. Third block is printed another shift. The innermost block is printed with a further shift. Okay, this is what we will also do in when we code. So few things you need to notice. What is the innermost block? The innermost block is the base case. That's the crucial observation. The innermost block is the base case, and so that's what that's an observation we have to keep in mind. And each of these calls are basically the recursive step. The call to a block inside is the recursive call which we make. So every again we come back to the properties of a recursive function. It basically will have two parts, a base case and the recursive step. Neither of them can be missed, both of them should be there, right? That's recursion for you. The next thing we are interested in is, how do I check whether the recursive function you have written is correct?